morning, students. Chapter 7, System of Particles and Rotational Motion. In last lecture, we have discussed about rolling motion. Okay, what is rolling motion? Transitional motion, rotational motion and rolling motion. Okay, and yes, we have discussed rolling motion on level surface. Okay, what is conclusion? Conclusion is okay, rolling without slipping. Its motion is combination of translational motion, means linear motion, and rotational motion. See, I will write a statement again here. Okay, when a body is rolling without slipping, rolling without slipping, its motion is combination of translational, or you can say linear motion and rotational motion. That we know. Okay. Yes. Center of mass of body performs linear motion, translational motion. Okay. Linear motion. And body itself performs rotational motion. Okay, so yes, we know this conclusion from last lecture. Okay, rolling motion is combination of two individual motion, that is translational motion and rotational motion. Okay, now we will see in today's lecture motion of object, rolling motion of object on inclined plane. So for that I am assuming, see, let one object having mass and its geometrical radius r, its radius of gyration k. Okay, let one object of mass m, geometrical radius r, and radius of gyration k is rolling down without slipping from top of an inclined plane of height h and angle theta. Okay, so again, one object having mass m, geometrical radius capital R, radius of gyration k, is rolling down without slipping from top of an inclined plane of height h and angle theta. See, like this. Okay, let it is angle theta and this height is h. An object is initially here at top in rest condition. And yes, about this axis, okay, about this axis, it is rolling down. Clear? Okay, so yes, this situation. The object is rolling without slipping from top of an inclined plane of height h and angle theta from rest. rest. From rest means initially it is at rest condition. Simple. Clear? Yes. Okay. Now what happens? See, in this situation, initially this object is at top of slope. Top of slope means at high edge. At high edge. So at this point it has some potential energy, and as it is at rest, its kinetic energy is 0. Yes, simple. Again, initially object is at top of slope, so it has some potential energy, its kinetic energy is 0. As it is rolling down, height decreases, means potential energy decreases, and according to law of conservation of energy, its kinetic energy increases. Simple. When it reaches bottom, okay, its potential energy becomes 0, but its kinetic energy becomes maximum. So, in easy way we can say, at top it has potential energy. When it rolls down without slipping and reaches to bottom, its potential energy is converted in kinetic energy. Clear? Easy? So, as body is rolling down, its potential energy decreases, and total kinetic energy increases. Simple? Yes, it is simple. Yes, it is simple. Clear about this? Okay, as body is rolling down, its potential energy decreases and its kinetic energy increases. At bottom, what happens? So its total potential energy is converted in total kinetic energy. At bottom, its potential energy is totally converted in total kinetic energy. Clear about this? So how to write equation? Okay, therefore potential energy at top is equal to total kinetic energy at bottom. Clear about this? How to write this equation? Potential energy at top is equal to total kinetic energy at bottom. Okay, now you have to write equations. Okay, how to write equation? What is equation of potential energy and what is equation of kinetic energy? See here how to write. Potential energy at top means it is m, mass of object is m, g, and its height is h, so it is mgh, is equal to total kinetic energy means, see here this statement, rolling without slipping motion is combination of translational motion and rotational motion. So in this case what happens? Total kinetic energy means linear kinetic energy plus rotational kinetic energy. Linear, or you can write translational, okay, as we have discussed earlier. So here now how to write equation? Okay, mgh is equal to linear kinetic energy. What is equation of linear kinetic energy? Yes, its equation is, it is half mv square plus what is equation of rotational kinetic energy? Okay, from table you can say it is half I omega square. Clear about this? Yes, this equation is important. This equation is important. Okay. Yes, rolling without slipping is combination of linear motion and rotational motion. That's why total kinetic energy is a sum of linear kinetic energy and rotational kinetic energy. Clear about this? Now we know that. I will write here. Okay. Now we know that I is equal to mk square. Yes, I is equal to mk square. And one another equation, that is V is equal to, it is omega r. So omega is equal to, it is V upon r. So I will write these two values here. So therefore mgh is equal to half mg square as it is plus half I is replaced by mk square. Omega is equal to V upon r. So omega square is equal to, it is V square upon r square. Simple? Yes, it is V square upon r square. Now see here it is. Therefore mgh is equal to half V square. So it is common V. So half V square common. So in bracket it is only 1 plus, it is k square upon r square. It is 1 plus k square upon r square. So yes, it is anchored. Okay. Now as you have to find, what is question? Obtain the formula of velocity. Okay. You have to find what is equation of velocity. Here at this point velocity is 0 because it is from rest. Here at bottom, what is velocity? That is your question. Okay. So mgh is equal to, it is half mv square 1 plus k square upon r square m cut. Now you have to make this v square as subject. 2 g h. Simple. And this whole term you have to write in denominator. That is 1 plus k square upon r square is equal to v square. So therefore v is equal to under root 2gh upon 1 plus k square upon r square. And yes, you have to remember this equation. The velocity at bottom of an inclined plane for object rolling without slipping is v is equal to under root 2gh 1 plus k square upon r square. Now see 2, that is 2, g, that is g, h is height of slope, 1, that is 1, k is radius of gyration, and r is geometrical radius. Now see, it is one general equation. Yes, for different objects from that table, okay, about moment of inertia and radius of gyration, you have to put value of k and you can easily find. For example, it is unknown object, but if I say it is one ring, so case 1 is suppose for ring. So for a ring, you know that k is equal to r. Yes, we have proved. For a ring, you know that radius of gyration k is equal to its radius, that is k is equal to r. So in above equation, you have to put k is equal to r. Simple. So what happens? K is equal to, it is under root 2gh upon 1 plus k is replaced by r, so it is r square upon r square. So r square cut. So it remains only 1. So 1 plus 1 it becomes 2. So it is equal to, it is under root 2gh upon 2. So it is under root gh. Simple. It is under root gh. So for different objects, ring, disc, sphere, cylinder, yes or no? Okay, for different object, just you have to remember value of k, that is radius of gyration. Okay, yes, how to ask different questions. One ring is rolling down, one sphere is rolling down, one cylinder is rolling down. You have to remember this equation and put value of k for given object. Clear about this? Okay, so yes, it is one question for this rolling motion on inclined plane, that is obtain formula for velocity at bottom. Formula for velocity at bottom. Clear about this? Okay, again from top, from rest condition it starts its motion, rolling without slipping. Its total potential energy is converted in total kinetic energy. Total kinetic energy means linear kinetic energy plus rotational kinetic energy. Equations. You have to remember this equation. Clear about this? Okay. So yes, it is one important theory for rolling motion. Okay. Okay, next theory question is obtain equation of acceleration parallel to slope for object rolling without slipping on inclined plane. It means, see here it is. It is again angle theta, height h, object starts its motion from top above this axis. Here initial velocity is 0. At bottom its velocity, now we know that v is equal to, it is under root 2gh upon 1 plus k square upon h square. Okay, what is question? Question is when object is rolling down without slipping on this inclined plane, what is acceleration parallel to slope? What is acceleration parallel to slope? That you have to find. Okay. How to find this acceleration parallel to slope? I am assuming the length of this slope. Okay, not height. Okay, length of this slope is d. Length of this slope is d. So yes, I have to write, okay, the length of slope is d. Okay, now see data. Initial velocity is 0, it is final velocity, acceleration and distance. Hello, yes or no? Yes it is. Initial velocity is 0, distance d, acceleration and v. What is relation between these four quantities? Yes, you know equation, right? From equation v square minus v0 square is equal to 2ax. X is replaced by d. Okay, from equation v square minus v0 square is equal to 2ad. Chalo v, that is final velocity at this point. Okay, so what is v square? V square, sorry. What is v square? V square means it is 2gh upon under 1 plus square upon r square. So it is v square. V0, initial velocity is 0, is equal to 2a. So yes, it is 2a. What about d? D means this. Now see, triangle. Here. See triangle. It is theta angle. H and d. Theta. This H is opposite side of angle. H is opposite side of angle and it is hypotenuse. So opposite side, for opposite side, which trigonometric function you have to consider? So yes, which trigonometric function you have to consider? Yes, sine theta. The sine theta is equal to opposite side upon hypotenuse. So yes, what is D? D is equal to, it is H upon sine theta. D is equal to, it is H upon sine theta. So see, V square, its value. V0, its value. 2, that is 2. A, that is A. And D you have to put, it is H upon sine theta. It is H upon sine theta. Clear about this? So therefore, here it is 2gh upon 1 plus k square upon r square is equal to 2ah divided by sin theta. 2 cut, 2 cut, h cut, h cut. We have to find what is acceleration parallel to slope. So you have to make a as subject. So therefore a is equal to, it is g sin theta upon 1 plus k square upon r square. It is equation of acceleration parallel to slope for object rolling without slipping on inclined plane. Clear about this? So yes, again it is one general equation that you have to remember. The acceleration a is equal to, it is g sin theta upon 1 plus k square upon r square. 1 plus k square upon r square. General equation means, again for example, I am taking object ring, and for ring you know that k is equal to, it is r. K is equal to r. So put here k is equal to r. So a is equal to, it is g sin theta upon 1 plus r square upon r square. R square cut. So it is 1. So 1 plus 1, it is 2. So therefore acceleration a is equal to, it is g by 2 sin theta. It is g by 2 sin theta. If you are given value of angle, that is a slope, then you can easily find what is acceleration. Okay, for example, for case of disk, k is equal to r upon root 2. So put k is equal to r upon root 2 and calculate. You will get acceleration parallel to slope for sphere. Clear about this? Clear about this? Okay, so yes, you have to write, you have to remember this general equation. Now, there is one important point. Okay, you know chapter 5, that is laws of motion. Yes or no? Yes, laws of motion. See here. Okay, here theory is over. Okay, here theory is over. It is one extra point, that is note. Okay, I have these two figures. Angle theta, angle theta, angle theta. Okay, height h, object, yes, object. But I am taking two different situations. Here, object is slipping, and here object is rolling, and here object is rolling. Means slipping means here it is performing only translational motion. It is performing only translational motion. So in translational motion, remember what is acceleration parallel to slope. If you remember that equation, okay, in here if it is object, then mg is in downward direction. It is mg sin theta, and here it is mg cos theta. But it is for force. For acceleration is equal to force upon mass. So yes, what about acceleration? G, it is in downward direction, parallel to slope, acceleration is g sin theta. Parallel to slope, acceleration is g sin theta. Parallel to slope, acceleration is g sin theta. So in case of slipping, that is for translational motion only, parallel to slope, acceleration a is equal to g sin theta. And here a is equal to, it is g sin theta. But in case of rolling motion, parallel to slope, acceleration is a is equal to g sin theta upon 1 plus k square upon r square. Yes, here a is equal to g sin theta upon 1 plus k square upon r square. Okay, so yes, you have to remember this one difference. Okay, what is difference? In slipping means transitional motion and rolling motion. In this case, acceleration parallel to slope is g sin theta, while in this case, acceleration parallel to slope is g sin theta upon 1 plus k square upon r square. And it is very clear from figure and equation that this acceleration is smaller than this acceleration, because here it is only g sin theta. Here it is g sin theta divided by 1 plus k square upon r square. So in rolling motion, rolling motion, acceleration parallel to slope, acceleration parallel to slope decreases. It decreases, yes or no? And it decreases because friction. It decreases because friction. Clear about this? It decreases because friction. Okay? And due to that friction it is rolling. Due to the friction it is rolling. So what is friction force acting on object while it is performing rolling motion? Yes, we also have to obtain that equation. Okay, and we will obtain this equation in next lecture. Okay, so yes, it is again one question, that is obtain equation of acceleration parallel to slope for object rolling without slipping on inclined plane. And this point, yes, this point is important. Okay, what is difference between these two cases? Clear? Okay, so yes, for today this is it. Okay, this is it.